think could occur. You write a lot of reports, you do a lot of summaries, and so you naturally have to not only understand the material that you're reviewing, but you have to be able to maybe write that in a form that someone who's maybe non-technical can read.
I'm an area consultant. Basically, I'm supporting the manufacturing process, the wastewater treatment process. In this particular assignment, my daily function is the special project that we're looking at waste minimization across the plant or reduction of waste loading to the treatment plant. Right now we have one of the largest industrial waste treatment plants in the United States, and we have a certain amount of investment on the ground. So we're looking at how can we maximize the use of that investment, how can we reduce the investment and still meet the requirements of the commercial business that we support for wastewater treatment and the wastewater treatment that we do for the plant. So we're actually going into the process, the manufacturing areas, and looking at what they generate, how they generate it, and how it's treated, and whether that makes the most sense. Typically I'll come in, I check my email, see what emergencies happened over the night. Is there anything that I need to respond to? There's a morning meeting 3 days a week, so if it's Monday, Wednesday, or Friday, you go to that. That's about a half hour or so. That's just what has happened overnight, what happened over the weekend, what's going to happen during the day, making sure jobs get planned well. And then I go into my specific tasks, so that's usually going over data that I've received from the areas, going over flow diagrams, trying to quantify these waste streams, calling the people in the areas who've provided data, asking questions, going out to their buildings if that's necessary to understand, what the process is doing, and then meeting with the other people on my team. We all work together about what are the next steps going to be, how are we going to address this problem, what are the different issues that we all handle.
I work as a process design engineer for the Richmond refinery. I work on a lube oil hydrocracking plant. It seems like when you come in at 7 o'clock in the morning, you could find the plants running really well, and you have an opportunity to work on something that's not a crisis. But most mornings there's some problem going on that we try to address using the data that's available on the computer, data that's available in the field, talking with the people operating the equipment. We try to assimilate all that information into discovering what the problem is and use some of the technical information we learned in class to solve the problem and fix it or optimize around it and move on. My typical day starts off about 7 o'clock in the morning, usually when I get into work. We have computer screens that we can pull up information about how the plants are performing. We use information that we learned in school to try to figure out if there's opportunities to optimize the process, either increasing pressures and temperatures or lowering pressure and temperatures to just try to make more lube oil. After looking at data on a computer, we then usually go down to the control room where the operators sit. Those are the people who are running the plant every day. We interface with them on a daily basis. We usually develop a good relationship with them. Usually discuss with them any opportunities that we've seen that might be available to optimize lube oil production. If we feel that it's a good thing to do, then we go ahead and try it. We track the response, see if the lube oil production actually increased, and if it did, then we try to document why it worked and how we should be operating the plant so that the next operating crew comes on, carries that idea forward, and keeps the optimization process going.
Right now I'm doing a startup of a clinical manufacturing plant. So my typical day involves coordination with other groups to see what equipment they're going to be using, coordination with the automation group to find out what they can support us on, and coordination with the manufacturing area to make sure that we have the utilities that we're going to require. I deal with a lot of the new equipment that we've installed and just doing the initial wet testing. But when there are emergencies, it's not unusual for maintenance to give me a call or for manufacturing to call me and ask me to help them in an area that I'm familiar with. For cell culture fermentation, the process deals with making up the nutrients to support the cell growth, growing the cells in large tanks that we call fermenters. And then my job extends to the initial stages of the recovery, the purification and the harvesting.
A pharmaceutical drug is not made in one step. There are many steps to making it. Usually one campaign, which is to deliver X number of kilos of drug, takes on the order of 4 to 7 months. So if you're running in the pilot plant, you're there every day, you're talking to the personnel, talking to the chemist, making sure the reaction's going correctly, your yields are right, and that sort of thing. At the same time, you could be working in the lab on the next step, designing it, improving it, making sure it'll work properly for when it goes into the pilot plant. So it can be any number of things.
I work mostly with chemical engineers.
I work with operators who actually run the units and keep them running 24 hours a day. I work with other engineers.
Mechanical engineers, piping engineers, civil structural.
In the very beginning of a project, it's mostly process engineers that drive the work. We're kind of the instigators, so to say.
In my case, a process engineer works with the process science people, the researchers who design the process, and the manufacturing people.
We work with lawyers, biologists, statisticians, toxicologists, biologists. All these people kind of bring their own expertise together.
I work with PhD chemists and engineers that work at our research center, and chemists, and I work with lab techs, and I work with managers, and really a huge variety of technical people.
Also, we deal with the customer sometimes, so we have a client interaction. And we also work with our business side.
But once the ball gets rolling, you have many disciplines that join, and that's when the process engineers' work really becomes exciting, because you have all these different disciplines. You've got mechanical engineers, electrical engineers, process controls people, you have piping designers, you have piping layout people, and they all have to come to you for information, basically, because you started it all. And a project, you could have 20, 25 people on an average project, anywhere up to over 100 on a large project.
Dealing with the contractors and dealing with other people on site or either outside of the company really helps to broaden your view of what an engineer can do.
All the equipment in a refinery is all reactors, distillation columns, heat exchangers, all the equipment that chemical engineers are specifically trained how to evaluate, design, and use in their chemical engineering classes.
I guess some of the courses that I found very helpful were unit operations. That probably was those are my favorite courses, the fluid mechanics and heat transfer and mass transfer. And actually a lot of the modeling and things that we do for the occupational exposure does use a lot of this mass transfer principles in it.
Most of the skills that I'm using now are the process skills that you learn in chemical engineering. Not so much from a chemical process standpoint, but the process way of thinking, the engineering method of how you develop programs, how you think logically through what needs to be accomplished and what are the steps that it'll take to get to that point.
The engineering that I've gotten from my education is more towards the writing abilities, the problem solving. It gives me a better viewpoint on what I'm doing. Like if I'm doing some testing and I see some from the results show this, I can say, well, that's because of the chemicals that are in this.
Engineers by nature are problem solvers. School, I think, really developed the systematic approach to solving problems.
I think it's very important to focus on their writing skills and take as many writing courses as they can.
You definitely need to know how to use a computer, and you need to have basic computing skills. You need to be able to use, some type of word processing program. Definitely Excel. Become a wizard at Excel. And if you're in any type of corporate environment, become a wizard at PowerPoint, because you'll be doing lots of presentations.
I do a lot of number crunching on the computer. My job consists mainly of data analysis and design of experiments.
When I build experimental designs in the laboratory, a lot of these software packages crunch out the numbers and give you a sense of where the data is falling.
I use my computer every day, whether it's as simple as reading email, all your memos, you write your own memos. Secretaries don't do this. You write your own memos, or writing your trip reports, plant trial results, all these things are on the computer.
Well, I've always been a very curious and creative person. Even when I was a child, I always enjoyed math and science. And so when